Let us study in detail about extraction of aluminium. Now, aluminium metal, its atomic number, mass number, electronic configuration, first I will show you. Aluminium, its atomic number is 13, mass number 27, its electronic configuration 283, its valency 3. Then we can say that its color is silver white. Again we can say that it is available in the nature abundantly. We can say that it is the third most abundant element in the Earth's crust. Now here I am giving you 9 most abundant elements which are available in the Earth's crust. First one, that is oxygen. Oxygen available in the Earth's crust 46%. Afterwards silicon, that is available 28%. This is the first most abundant element which is available in the Earth's crust. That is oxygen 46% present in Earth's crust. Then silicon, that is available in the Earth's crust, that is 28%. Third one, that is aluminium. It is available 8.3%. The fourth most abundant element, that is iron, Fe, iron. It is available 5.6% in the Earth's crust. Now the fifth element, that is calcium, that is available 4.2%. Then the sixth element, that is sodium. It is available 2.5%. Then magnesium, Mg, that is available 2.4%. Then potassium, K, potassium, that is available 2%. Then the ninth most abundant element, that is titanium, that is available 0.61%. So here I shown now 9 most abundant condition available in the Earth's crust. They are oxygen, silicon, aluminium, iron, calcium, sodium, magnesium, potassium and titanium. Now here we are studying about this aluminium. It is available 8.3% in the Earth's crust. Now what is Earth's crust? Earth's crust means under the earth up to 30 kilometers under the land. I am saying you, under the land up to 30 kilometers. So earth crust, its meaning. Earth crust means, first thing, up to 30 kilometers under the land. And one more thing is there, and up to 5 kilometers under the ocean. So up to 30 kilometers under the land and up to 5 kilometers under the ocean, we say as Earth's crust. Now in that Earth's crust, these all elements are available most abundantly. Now here we people are studying about aluminium. Aluminium available in the ore, or we can say that the ore of aluminium, that is known as bauxite. Bauxite is the, or bauxite ore we can say, this is the ore of aluminium. Aluminium is not available freely in the nature. Why? Because it is a reactive metal. So we can say that aluminium is a reactive metal not available in the free form. Not available freely in the nature. Why? Because it is a reactive metal. Because of that, it is not available freely in the nature. As and when remove out from the earth's crust, the bauxite ore will have large number of water molecules. After concentrating that ore, maximum quantity of water molecules will disappear. So, two formula of bauxite I am showing. So, one formula, that is how it is available from the nature. That particular time, large molecule of water will be there. So, we can say that original form of bauxite, its formula, that is aluminium oxide, Al2O3. Along with that, N number of water molecule. N shows that large number of water molecules. So this we can say that this is a raw or original form of bauxite. Raw or original form of bauxite. So this formula is the raw form or original form of bauxite. Then after concentrating that ore, now concentration process we will study. So after concentrating the ore, we will get bauxite, its formula containing only 2 molecules of water. Al2O3 dot 2 molecules of water. So here now after concentrating the ore, the bauxite ore will have only 2 molecules of water. So here we can say 1 molecule of bauxite containing 2 molecules of water. Now here in chemical reactions we are writing this formula for bauxite. Now we will study how to concentrate bauxite ore. For concentrating bauxite ore, we have to follow 2 methods. Either Bayer's process or Bayer's method we can say, or we can use Hole's method. Or Hole's process. So Bayer's method, here again I am writing now Bayer's method as well as Hole's method. Or we can say as Bayer's process or Hole's process. Now in Bayer's process we are using sodium hydroxide. In Hole's method we are using sodium carbonate for dissolving bauxite ore. So this is the bauxite ore. Now for dissolving this bauxite ore we are using sodium hydroxide in Bayer's process, sodium carbonate for dissolving aluminium ore, or we can say bauxite ore, sodium carbonate formula Na2CO3. Sodium carbonate formula Na2CO3. So sodium carbonate we are using for dissolving aluminium ore or bauxite ore. Now in the bauxite ore there will be some impurities, we can say gangue particles. So which all impurities will be there along with the bauxite? That is one, silica. Silica we can say that sand particles. Second thing I can say that is iron oxide. Iron oxide. That is iron oxide means a ferric oxide, Fe2O3. Then the third one, that is titanic oxide. Titanic oxide. Or we can say as titanium oxide. Its formula TiO2. Titanium oxide or titanic oxide. Now silica or sand, its formula SiO2. Silica, its formula, that is sand, its formula SiO2. Now here how they are concentrating this bauxite ore we will study now. First they are taking a large container. In this large container, they are putting powdered, or we can say crushed, powdered ore. Which ore? Bauxite ore. Now, how they are making powdered ore? For that, they are using a machine. That machine is known as ball mill. Its name is ball mill. Now, what is ball mill? You people already aware of this grain mill. Grains we people are taking for milling it, powdering it. For that we are taking, that means wheat and all we are taking into the mill. So that mill you are knowing. Here now other mill, that is known as a ball mill. Its shape is almost cylindrical. Cylindrical container I can say. Again from here one inlet will be there. Inlet means putting the bauxite ore inside. Here one exit will be there. Exit, or I can say that outlet will be there for coming out the powdered bauxite into the container. Again here mechanical connection will be there, electricity flow will be there. For that all means connecting wires as well as mechanical arrangement will be there. Now only the main, that is cylindrical container, in that what will be, that only I am explaining. Through this inlet we have to put the bauxite inside. Now how much is its size? It's 50% of ore only we have to put it inside. Full filled condition not to put it, 50% of ore we have to put it, or less than that, beyond that not required. Now inside this there will be steel balls will be there. Inside this cylindrical container there will be steel balls. These all balls are made with steel, stainless steel we can say. Steel balls are present. As and when the machine starts working, that particular time these balls will move here and there. As a result of it, they will, that means with a forcible manner, these balls will move in the cylindrical container. As a result of it, they will collide, they will hit on the bauxite ore. As a result of it, powdering of bauxite ore will take place. Now bauxite ore containing, I said you, different types of gangue particles like iron oxide, silica and titanium oxide will be there. Now plus these three gangue particles plus exact or real bauxite, that is aluminium oxide. These all things will become powdered because of the collision between these balls. Again one more thing is there. Once these balls will hit on them, they will become small pieces. Again this process will be continued. As a result of it, the pieces of ore which is formed, again they also will collide with each other. As a result of it, powdered form of ore will become. That powdered form we have to collect it in a container. That powdered ore only I am taking here. Now in this we have to add, this I am explaining about Bayer's process. Here I am explaining now Bayer's process or Bayer's method. So here I am adding now sodium hydroxide solution, NaOH solution. So here we can say that powdered ore is there. Again in that is sodium hydroxide solution added. After that we have to heat this container and heat this mixture. We have to first, after adding, just we have to mix it. Afterwards we have to supply heat up to we can say that for 140 degree to 150 degree Celsius temperature we have to supply. Then this container we can call as digester. We can say that this process of reaction of sodium hydroxide with bauxite ore will take place up to 8 hours, I can say. That is 2 to 8 hours this process will be taking place inside this digester. As a result of it, now temperature how much constantly we have to supply? Up till 150 degrees Celsius temperature. As a result of it, we can find that here bauxite ore, its formula Al2O3.2H2O, that will react with the sodium hydroxide. As a result of it, we can say that there will be the formation of sodium aluminate, NaAlO2, sodium aluminate. Sodium aluminate. Along with that, water molecules. So here we can say that as and when heat supply will be taking place, this ore, that is aluminium ore or bauxite ore, will dissolve or we can say will react with the sodium hydroxide. As a result of it, sodium aluminate as well as water will form. Then this sodium aluminate is will be in the highly concentrated condition. Then what we have to do? This separation, how it is taking place, that I'll say you. But first, what is forming? Then its diluting process again we have to do. After diluting it, that means a diluting process is taking place with the water. As a result of it, here the formation of aluminium hydroxide as well as sodium hydroxide will take place. So before that, which all process is taking place, I will say you. First thing, so this bauxite ore will dissolve in sodium hydroxide. But we have studied that in the bauxite ore, other gangue particles will be there. Which all gangue particles are there? Silicon dioxide, sand we can say, then ferric oxide, that is iron oxide, Fe2O3, and one more thing, that is titanium oxide or titanic oxide, that is TiO2. Now, along with the aluminium oxide we can say Al2O3, then 2H2O. So we can say that all these things together is present here in the bauxite. Now, as and when sodium hydroxide we add, this aluminium oxide, that will dissolve inside the sodium hydroxide. Even I can say that this thing one, the second thing, that is even silicon dioxide or silica also will dissolve inside the sodium hydroxide. So aluminium oxide and silicon oxide, or we can say silica, this is aluminium oxide, both of them can dissolve in sodium hydroxide. So one thing I shown here, aluminium oxide dissolves in sodium hydroxide. Second thing I am saying you, that is silicon dioxide, that again can dissolve in sodium hydroxide. As a result of it, here will be the formation of sodium silicate, Na2SiO3. So here we can say that the formation of sodium silicate as well as there will be the formation of water. So here these two things will dissolve in sodium hydroxide. Remaining these two things do not dissolve in sodium hydroxide, so they will collect downside. Here the collection of iron oxide as well as titanium oxide will be there. Other things, this and this will dissolve in sodium hydroxide. Then these things we have to filtered out. We have to filtered out. The liquid matter we have to remove out. Solid things will settle down. Later these things will come out. Then these things we can be able to throw it out or remove it out. Then again, if here in these two metallic oxides, if more quantities of iron is present or titanium is present, again they can separate it. But here our intention to separate only aluminium from aluminium oxide, or we can say bauxite ore. So remaining things we are removing out. But these two things we filtered out, we removed. But here again we can say along with this this will be present. So we can say that here now both the things are dissolved in sodium hydroxide. Here aluminium or aluminium oxide with water molecules, I can say, that is reacted with the sodium hydroxide. As a result of it, sodium aluminate formed. Here silicon, this silica. Silicon means Si only. This is silicon. Now this is silicon dioxide that reacts or dissolves with the sodium hydroxide. As a result of it, sodium silicate is formed. Now, this process, here it is stopped. We have got now this substance, that is sodium aluminate we have got, sodium silicate we have got. Now these two things we have to dissolve or we have to pour water in the container. So we can take these things now in a container. This part remove it. Then afterwards what we are doing, these things we are taking in a container. In a container, we are taking now sodium aluminate, NaAlO2. Then again this substance also we have to take it because both the things will be there in this container. From that only we removed out. Now the things which we removed out, filtered out, that is present here, that is Na2SiO3. We can say that sodium silicate. Now downside settled things, iron oxide as well as titanic oxide, that we have to separate out, this we have to separate out. So this is in the liquid form, so easily we can be able to pour it out. That I collected, or that we have to collect it in a container. Now we can say that this thing, now when it is removing out, it will be having high temperature, that is up to 140 degrees Celsius to 150 degrees Celsius. Now we have to dilute this mixture by pouring water. We have to pour water inside. As a result of it, we can say that the temperature of the, or we can say that till when we have to pour the water, till the temperature of this mixture reaches up to 50 degrees Celsius. Here up to 150 degrees Celsius temperature is there. That solution, that aqueous medium, or we can say solution, we removed out in this container, and for reducing its temperature, we are adding water inside. The speciality of water as well as this thing, this substance can dissolve in water and sodium aluminate can react with the water. So here as and when we pour water, this will dissolve with the water and sodium aluminate will react with the water. So we'll see now. Here in this is already dissolved, so we can say that now the container, in this sodium aluminate will react with the water. Now the other thing will dissolve in water. As a result of it, it will collect upside. In the liquid form it will be there. Then this liquid form we can separate out. So as a result of it, this thing, that is sodium silicate, that will dissolve in the water, that we can separate out or filtered out. Now here the sodium aluminate as well as water will react. As a result of it, we will get one more compound, that is the third reaction I am saying, that is sodium aluminate, AlO2, that reacts with the water. As a result of it, aluminium hydroxide as well as sodium hydroxide will form. So here now sodium aluminate reacted with water. As a result of it, aluminium hydroxide as well as sodium hydroxide is formed. Now this aluminium hydroxide will be precipitated. Precipitated means it is solidified. Then that solid form will be collecting downside, that we can be able to separate out. Sodium hydroxide we can remove out. Afterwards, further step we have to do, that is electrolytic process. So here now we studied about the Bayer's process. Now we will balance and see whether these equations are balanced or not. Here now Al2O3 dot 2H2O reacted with the sodium hydroxide. As a result of it, sodium aluminate as well as water formed. Second reaction, silicon dioxide or silica reacted with the sodium hydroxide. As a result of it, sodium silicate as well as water formed. Third reaction, sodium aluminate reacted with water. As a result of it, aluminium hydroxide, AlOH3. OH, its valency is 1. Aluminium, its valency 3. AlOH thrice plus NaOH. Now we will balance. Here aluminium 2 is there, but here aluminium only 1 is there. So I am putting here now 2. Then oxygen here 3, 3 plus 2, 5 oxygen plus 1, 6 oxygen. Here 2 2s are 4 oxygen, 1 5. So here single is there, so I am making it a double. Now here sodium, its number 1 is there, here 2 is there. So I am making here now 2. Now we will count and see. Al2, here Al2. After that oxygen 3 plus 2, 5 plus 2, 7 became now. Here how many? 2 2s are 4, 4 plus 2, 6. Here now 3, 3 plus 2, 5, 5 plus 2, 7 became. Here now sodium's number 2, so I made here sodium 2. Now one oxygen is more, so I am trying to put here now. One more, 2 I was put, now I made now 3. Now let us see how it is coming. Hydrogen's number also we need to see. I think it is balanced now. 2 2s are 4, 4 plus 2, 6. Here 3 2s are 6. 6 hydrogen became. Then oxygen's number 2 2s are 4, 4 plus 3, 7. Here 2, 2 plus 2, 4, 4 plus 3, 7. Aluminium 2, aluminium here 2. So then equation balanced. So once again we will see aluminium here 2, here also aluminium 2, oxygen 3, 3 plus 2, 5, 5 plus 2, 7. Here 2 2s are 4, 4 plus 3, 7 oxygen. Then here hydrogen 2 2s are 4, 4 plus 2, 6. Here 3 2s are 6. So hydrogen correct became. So equation is in balanced condition. Here also 2 2s are 4, 4 plus 2, 6 hydrogen. Here also 6 hydrogen. So both the side, while balancing we have to see that reactant side and product side there should be equal number of atoms of the elements. Now we will see here. Here silicon Si. Here Si 1. Here also 1. Oxygen here 2. 2 plus 1 3. Here now 3. 3 plus 1 4. 4 is there. So here if we put 2, what will be the condition then? Here now oxygen here 4 is there. Here not alone this thing, here also single condition is there. So I am making here 2 Na is there. So here only 1 is there, so here I am putting 2. So we will see now 2 Na, here also 2 Na is there. Oxygen's number we will see 2, 2 plus 2, 4 now. Here 3, 3 plus 1, 4. Silicon here 1, here silicon 1. Sodium, hydrogen here 2 hydrogen, here also 2. So equation balanced. Once again we will see silicon 1, silicon 1. Oxygen 2, 2 plus 2, 4. Here 3, 3 plus 1, 4. Afterwards sodium here 2, here also sodium 2. Hydrogen then here 2, here also 2. Equation balanced. Now here sodium here 1, here sodium 1. Aluminium 1, aluminium 1. Hydrogen here 2, 2 plus 1, 3. Here hydrogen, oxygen. Oxygen here 2, 2 plus 1, 3. Here oxygen 3, 3 plus 1, 4 is there. This side 4 is there. 4 oxygen. 3 inside the bracket. So 3 oxygen plus 1 oxygen. 4 oxygen. Here 2 is there. Here only 1 is there. So where 1 is there, there I am putting 2. Now we will see oxygen's number 2, 2 plus 2. 2 plus 2, 4. Here now oxygen's number 3 plus 1, 4. After that hydrogen's number here 2 2s are 4. Here 3 hydrogen plus 1, 4. So then this equation also balanced. So here now 3 equations we need to study in this particular reaction, or we can say concentration process by Bayer. So here what all reactions happen? This bauxite ore at first reacted with the sodium hydroxide. As a result of it, sodium aluminate as well as water became. That sodium aluminate again reacted with water. As a result of it, aluminum hydroxide as well as sodium hydroxide became. Here for removing silica or silicon dioxide, what is happened? Silica reacted with, that means here bauxite can react with the sodium hydroxide. Similarly, silica also can react with the sodium hydroxide. As a result of it, sodium silicate is forming. But sodium silicate can dissolve in water. As a result of it, we can be able to filtrate out this sodium silicate along with water. Then only sodium aluminate will be there, that can be able to react with water. As a result of it, at which temperature? 50 degree Celsius. At 50 degree Celsius, till the time means we have to keep on pouring water. At 50 degree Celsius, we can say the reaction between sodium aluminate as well as water will take place. As a result of it, aluminium hydroxide and sodium hydroxide will form. Now we will study concentration of bauxite ore by Hole's method. In Hole's method, for leaching process, we are not using sodium hydroxide, we are using sodium carbonate. Now what is happening, we'll see. Remaining process, Bayer's process as well as in Hole's method, there the concentration process more or less same, only the chemical they are using, that is different. Here in Hole's method, they are using sodium carbonate, but at the same time in Bayer's process, they are using for leaching process sodium hydroxide. Leaching means just soaking work with soaking of ore with the sodium hydroxide or soaking of ore with the sodium carbonate. In Bayer's process, soaking of bauxite ore with the sodium hydroxide done. Here now in Hole's method, soaking of bauxite ore is doing with the sodium carbonate. Now we will study directly its chemical reaction. Here aluminium oxide, bauxite ore, its a formula Al2O3 dot 2H2O. Bauxite ore reacts with, that means it dissolves in sodium carbonate. This is Hole's method. Here we are using sodium carbonate. As a result of it, sodium aluminate NaAlO2, along with that water as well as carbon dioxide gas is forming. This gas is evolving out. Now here again the same, this is the product, this is the reactant. So here now what is there in the container, when we people are taking the bauxite ore and sodium carbonate, here we can say that the reaction of sodium aluminate formation will take place. Remaining things, sodium aluminate will be in which condition? Water soluble condition. So we can say that sodium aluminate is water soluble. Inside the water it can dissolve. Plus we can say that it will mix with it. At the same time other means the gang particles that will settle down, that can be able to remove out. Now here this sodium aluminate which is forming along with the water, this thing again we have to pass. Here as a result of the product which is forming, the same product I am using here again, that is NaAlO2 along with that water. Carbon dioxide gas already gone away. Now what we have to do further, we have to pass in this solution carbon dioxide gas. We have to pass it and we have to heat it. Warm condition we have to make it. As a result of it, we will get aluminium hydroxide AlOH thrice, along with that sodium carbonate Na2CO3 will form. Now this aluminium hydroxide AlOH thrice, that we have to filter it out, then we have to wash it, dry it, afterwards we have to heat it. As a result of it, here the formation of aluminium oxide as well as water will form. So this process is common for Bayer's as well as Hol's process. Bayer's method as well as Hol's method. In both the method, this final step we need to do. That means aluminium oxide, its speciality, it is a precipitate, solidifies, it will come, it will settle down. Then this liquid form will separate out, we can filter it out. After that, which is getting it, that thing we have to wash it well, afterwards we have to dry it, then we have to heat it, then heating process by calcination process. By calcination process, we have to heat it. Calcination means with less supply of oxygen, we have to heat it. As a result of it, we will get aluminium oxide from aluminium hydroxide. Now we will see here, this is Hol's method. Here only the chemical reaction is shown. Bayer's process, which all process is doing, process done or process is doing. By Bayer's process, same process only for Hol's process. Only one difference. Here sodium carbonate. In Hol's method, for leaching process, sodium carbonate is using, but in case of Bayer's process for leaching, sodium hydroxide is using. Then this is the bauxite ore, that is reacting with the sodium carbonate. As a result of it, sodium aluminate is forming plus water and carbon dioxide gas. Carbon dioxide gas is evolving out. Now in the same container we can say we have to pass again carbon dioxide gas. As a result of it, the formation of aluminium hydroxide, it will be in solid condition. So precipitation will take place. Then sodium carbonate will be in liquid form, that we can filter it out. This aluminium hydroxide we have to calcine. Calcine means by the process of calcination, we can separate from aluminium hydroxide aluminium oxide. Now we will study electrolytic reduction of alumina. What is electrolytic reduction of alumina? Electrolytic reduction, its meaning is electrolysis. Electrolysis means what? We have to pass electricity through the electrolyte. Here we are using the electrolyte as aluminium oxide. But the aluminium oxide, which is formed by the calcination of aluminium hydroxide, for that 1000 degrees Celsius temperature taken place or required. So for the formation of aluminium oxide from aluminium hydroxide, there is a requirement of 1000 degrees Celsius, and we can say that there should have the limitation in the supply of oxygen into it. Now we are studying in detail about electrolysis process of separation of aluminium from aluminium oxide. It is a reduction process. So we can say that metals are separating from its oxide or its chloride, or we can say that it's a compound. So we can say that that is a reduction process. We'll study in detail with the help of a diagram. Here we are using one steel tank, then its lining we are making with the help of graphite. Lining means it's the wall, inner wall, that is made with the help of graphite. Now here we have to keep an exit. Here one tank also we will keep. It's inside. We have to take aluminium oxide. That is only alumina. Its actual melting point is 2000 degrees Celsius. But when we add with this cryolite as well as fluorspar, F-L-U-O-R, S-P-A-R, fluorspar. Now cryolite, its formula Na Na3 AlF6. Na3 AlF6. This is the formula of cryolite. Then fluorspar CaF2. So we can say that here now we have taken aluminium oxide, then cryolite as well as fluorspar. Aluminium oxide, its melting point is very high. It requires 2000 degrees Celsius for melting. So for reducing its melting point, we are adding cryolite as well as fluorspar along with aluminium oxide. As a result of it, their melting point will reduce up to 1000 degrees Celsius. Cryolite is the formula Na3AlF6. Fluorspar, its formula CaF2. Aluminium oxide Al2O3. Now, in this part, this lining, graphite lining is acting as cathode. So we can say that it is negatively charged electrode. Now, inside this, we are putting few electrodes. This is again made with the graphite. This thing we have to connect with the cell. Here I am just separating it. Showing like this. Now connecting this cathode as well as anode with the help of positive as well as negative charged terminals of the battery. So here we can say that this small line represents negative terminal of the cell, big line represents positive terminal of the cell. Here we can say that this thing connected to the electrodes. So here we can say that these all electrodes are anodes, positively charged electrodes we can say as anode, and negatively charged lining, this lining, that we can say as cathode. So here cathode is there, here anode is there. These rods we can say as anode. Now we have to supply heat up to 1000 degrees Celsius. Now instead of 2000 degrees Celsius, 1000 degrees Celsius, when we supply heat, we can find that here mixing, or we can say melting of this aluminium oxide will take place. As a result of it, we can say that aluminium ion, Al3 plus ion, and oxide ion, O2 minus ions, they will separate. Now this Al3 plus ion will collect on the lining here. At the same time, this oxide ion will collect on the anode. Oxide ion will go to the cathode, will go to the anode. Here minus charged ion is there, that will go to the positive electrode. Positive electrodes are anode. Aluminium that is having positive charge is there, that will go to the cathode. Here now we can say that this particular part, aluminium is a metal, it is very heavy, molten condition, liquid condition we can say, that will come towards the lining. Which lining? Graphite lining, which is acting as a cathode. So there means we can say that attraction is taking place. Positive charged ions will go to the negative charged electrode. Negative charged ions will go to the positive charged electrode. Here positive charged ions are aluminium, that will go to the cathode. Then here oxygen is having negative charge, that will go to the positive electrode. So as a result of it, here cathode reaction as well as anode reaction will take place. Now at the anode what will take place, at the cathode what will take place, that we will study with the help of the equation. So here now at the anode, first we will study what is happening at the anode. Anode means here on these rods. Here we can say that one oxygen ion is going. So one oxygen ion is having 2 minus sign is there. this oxygen ion, once it will go there, it will transforms to oxygen atom. Oxygen atom it becomes, but one oxygen atom cannot exist alone. So what will do? One oxide ion transforms to one oxygen atom. Again that oxygen atom reacts with one more oxygen atom and it will become oxygen molecule. So on this anode, it will be remaining in oxygen molecule form, not in oxygen atom form. Once it will become, again it will react with one more oxygen atom, then oxygen molecule will become. Now here you see, one oxygen ion has 2 minus, but here 2 oxygen molecule is there. 2 oxygen molecule is meaning here there should be then 2 oxygen ions. Here 2 oxygen ions will be there, then one oxygen molecule formation. 1 O2 formation is possible. So here now 2 oxide ion. That means how many electron will be there? 2 2s are 4. So here we have to write 4 electrons will be there. Here 2 oxygen molecule became, one oxygen molecule, or we can say 2 oxygen atoms became because of joining 4 electrons with this, for the removal of, from this 4 electrons removed. As a result of it, here 2 oxygen atoms, or we can say 1 oxygen molecule is became. So here 1 oxygen has 2 minus sign, then here single oxygen. Now one single also I will show you. Oxygen 2 minus, then here will be single O and 2 E minus. But such a single O never exists. Because of that, here we have to use 2 oxygen ions. As a result of it, here O2 formation will become, then here there will be 4 electrons. Then the equation is balancing. So at the anode, here positive electrode, this reaction is taking place. Oxygen ions, once it will reach over there, it will gives its extra oxygen. Actually, while forming ions, oxygen receives electron from aluminium. But as and when it go and deposit on the anode, it will gives away its extra electrons and it will deposit on the anode in the form of atom or in the form of molecule. So here now oxygen cannot have any cannot exist in single. Because of that, it will exist in the form of molecule, O2 form. That is only shown here. Now we are studying about a cathode reaction. Now what is happening at a cathode? At the cathode. At the cathode means we can say that here lining of graphite is there, here aluminium ion coming and collecting. Aluminium's problem, what is there? Aluminium ions, it is already one aluminium atom lost 3 electrons. Like that way, number of aluminium atoms lost their electrons, 3 electrons. So in the ionic condition, they are coming towards the lining. That means we can say cathode. As and when it reaches here, cathode has full of electrons. They receive, these aluminium ions will receive electrons. Here what is happening? Oxygen ion removes. But here aluminium ions receives. So here I am showing you aluminium ion that is having 3 plus, it receives. 3 plus is there. One aluminium ion has 3 plus ions. So we can say that one aluminium ion has 3. Here 3 plus is there. It's meaning it is lost 3 electrons from it. So as and when it reaches here, it will receive 3 electrons. As a result of it, one aluminium atom forms. Aluminium atom has, single aluminium atom has, atom can exist. So aluminium atom can exist alone. Oxygen atom cannot exist alone. So they have to become oxide or oxygen molecule. Here oxygen single condition never exists. But aluminium can exist in single form. So here now one aluminium 3 plus ion receives 3 electrons. As a result of it, it becomes aluminium atom. So this is in atomic stage, this is in the molecular stage. Here single condition it cannot remain, because of that it here O2 we are seeing. But aluminium Al2 never. Aluminium Al alone enough. Why? Because single condition it can be able to exist. Now one more thing, as a result of this chemical reaction, here now this is made with the help of this positive electrode made with the help of graphite. This is again made with the help of graphite. Graphite means we can say carbon. Now these oxygen ions or oxide ions collected here, and as a result of reaching here we can say oxygen molecules formation took place. This oxygen is having the capacity to react with graphite. So we can say that graphite is made with the help of carbon. Now here oxygen molecules collected, deposited on it. So they both are reacting with each other. As a result of it, carbon dioxide gas is forming. So here we can say that this is made with carbon, oxygen molecules already deposited now at present. Then both of them reacting with each other. As a result of it, carbon dioxide molecule is forming. So we can say that here slow burning process is taking place. As a result of it, means after using few times, we have to replace these anode rods. Why? Because slow by slow, its size will reduce. Slow burning process. That means it is not a quick burning process, but slow burning process will take place. As and when this burning process will take place, carbon dioxide gas will evolve out and the size of the anode will reduce. Then they replace these rods with the other rods. So like that we can say that 1 week time, few time means minimum few days they will use it. After that they will keep again anode rods. This they will remove out, again new anode rods they will keep. So again and again they can continue the process of electrolytic reduction. Now we can see that here in this case oxygen, here this ion, here oxygen ion, or we can say oxide ion. So here it is receiving electron. This this oxide ion removing electron. Why? Because it is having extra electron. So here we can say that this oxide ion removing electrons which is received when it formed a compound. So how much electrons, how much ions it has? Here, how much electrons it has, that will remove out. Here we had already studied. At the anode, removal of electrons taking place. Then it become oxygen atom. Again oxygen atom is joining together, oxygen molecule is taking place. So here we can say that at the anode, removal of electron taking place. So we can say that this reaction is known as oxidation reaction. Oxide ions removing their excess electrons. So this process is known as oxidation reaction. At the same time, here aluminium, it is a metal. It is having positive charges. It is electropositive by losing its outermost electrons. Now, once it comes to the cathode, again it gains electron or it accepts electron. So we can say that that is reduction process. So here aluminium receives electron. So we can say that it is reduction process. Metals receive electron. Metallic ion we can say. Metallic ion. Aluminium is a metal. Similarly other metals. So metallic ions receives electron. So we can say that that is as a result of electrolytic reduction process we can say. So here now what is happening? Metallic ion receives electron. So we can say that that is reduction process, or there occurs a reduction process. At the same time, in case of non-metallic ions, they remove their electrons on anode we can see. So that reaction is known as oxidation reaction. Now we will study refining of metals. Refining of metals also a kind of electrolytic process. Before we had studied electrolytic reduction of alumina. Now we are studying refining of metals. Both of them are electrolytic process, or we can say electrolysis. But then what is the difference between both of them? In case of electrolytic reduction of alumina, their electrodes are carbon, or we can say graphite. Anode is the, in case of electrolytic reduction, we are using anode, that is graphite rods, cathode, that is graphite lining. But at the same time, in case of refining of metals, it is again an electrolytic process, but here cathode, that is the pure metallic piece, anode, that will be the impure metallic piece. With the help of diagram I will explain. Now suppose we have to do the refining of. Why we have to do the refining of metals? Because as a result of electrolytic reduction of metals or metallic compounds, we can say alumina, that is a metallic compound. From that aluminium separated, oxygen separated. Even then that aluminium won't be pure. There will be some impurities. Why? Because it is mixing with the carbon. Because carbon lining, on carbon lining it is collecting. So as a result of it, there is a possibility of reaction with the carbon. So we can say that the aluminium as a result of, or any metal, as a result of electrolytic reduction we collect. In that there will be some impurities. Then for getting 100% pure metal, we have to refine it. That refining process is electrolysis, we can say. Correct, electrolysis or electrolytic process. Now here see. For that we are using two electrodes. We can say one is cathode, the other one is anode. Two electrodes we are using. One is cathode, one is anode. Cathode is having negative charge, then anode is having positive charge. So we can say that anode is the positive charged electrode, cathode is the negative charged electrodes. Now here we have to use the electrolyte. This electrolyte will be the salt solution of the metal what we are using for purification. It's a salt solution, maybe oxide solution, chloride solution, carbonate solution, like that. So we can say that salt solution of the metal. Which metal we are purifying it, or we people are refining it. So for that, which metal we are using, it's a solution we have to use. It's a salt solution we have to use it. So here now, two electrodes I am using. So we can say that this is now cathode. So we can say that it will be the pure metal. Now this is the anode. This will be the impure metal. We can say that the metal which we people are getting it as a result of electrolytic reduction. Again that thing we have to refine it. So we can say that aluminium already we collected as a result of electrolytic reduction. That aluminium will be the impure metal. We can say that that will be the anode or impure metal. Now minus is shown, that is the cathode. So I am writing again here, this is the cathode. Pure metal will be the cathode. This is the impure metal already which is receiving from the electrolytic reduction process, that will be acting as anode. Now we are connecting both of them with the cell. Here we can say that this is the cathode, then small one I am mentioning. Here big one, that is for positive terminal of the cell. So we can say that positive terminal of the cell connecting to the anode, negative terminal of the cell connecting to the cathode. Now we can say that here the solution is there. That solution is the, now suppose if you are taking aluminium, here impure aluminium, here pure aluminium. Now this aluminium if you are taking, we can say that this electrolytic solution will be the salt of, or salt solution of aluminium. Aluminium chloride we can take, aluminium oxide we can take, aluminium carbonate we can take, like that way. So here we can say that aluminium, it's a solution. Aluminium plus it's a salt solution we can say. Any salt, that means aluminium chloride can be, aluminium oxide can be, like that. Now, as and when we pass current through this solution or through the electrolyte we can say. So current flow will be taking place from positive terminal and it will pass through this anode and it will pass through this solution electrolyte and it will pass through the cathode and finally it will reach to the negative electrode. As and when current flow through this electrolyte, we can find that this anode will dissolve inside this electrolyte. So we can say that anode, that is the impure metal, will dissolve in the electrolyte. So anode means the impure metal will dissolve inside this electrolyte, and through this electrolyte it will go towards the cathode. Then on this cathode, already cathode is the pure metal is there. On that pure metal, these metallic particles which are coming from the anode, that will go and deposit. Such a way we can say that 100% pure metals can be able to separate by refining of metals. Or means we had already studied this method, both the methods are electrolytic process or electrolysis. But refining metals, that process if we will use, we will get 100% pure metal. At the same time, electrolytic reduction if we use, their 100% pure metal won't be there. Why? Because their electrodes are using, that is graphite rods or graphite lining. So there means some impurities getting chances there. But at the same time, when we are using this refining of metals, their pure metal as well as impure metal and this metallic solution we are using it. So here the metal is going to collect on the pure metal. So as a result of it, their impurities formation is not going to occur. So as a result of this refining of metals, we will get 100% pure metal on cathode. Thank you.